Hello everyone. In today's video, we will see about attributes in geometry nodes. Attributes in general is used in all node sections, for example in shader nodes and texture editing, even for compositor, but we will be mainly focusing on geometry nodes and the attributes used in it. Okay, we'll create a new geometry node. If you have not checked about what is geometry nodes, I have a separate video for it. I'll give you the link in the description. I would recommend to check the geometry nodes and nodes in general in Blender, both videos, and then come to the attributes, because attributes is a bit advanced concept of a part of the geometry node. So having a basic idea of nodes and geometry nodes in general is essential. So what are attributes? Attributes are data stored per element in Blender. So this is the official statement they have. What it means is every geometry you see in the 3D viewport will have a set of attribute behind it which will define its whole appearance. For example, if we take this cube, which will come by default when you click on new geometry nodes, you can see on the spreadsheet editor on the far left you have vertex, edge, face and face corner. So these four attributes or attribute domains decides how this should look. What I mean by domains, each of the geometry will have a certain type of geometry type to it. For example, some will have point, some will have a curve, some will have edges, and then some will have just volume or point cloud or instance like that. Having a basic understanding of simple geometry shapes and the elements constructed is necessary. For example, if you take a circle, it's based on a curve, an arc, right? And if you take a cube, it's consists of lines and points. More than lines, it's just the points. And when you connect the points, you get the cube. So that's exactly what's going on with the vertex. So with 8 vertices, you can define this cube. So let's see a little bit advanced. We'll dive deep into the attributes. So we have the default cube created when you select or create the geometry nodes. We'll little bit dive deep into this. Let's put a mesh to curve into the mix. So this will convert the mesh cube to set of curves and then gives it an output. Okay, so what difference does it make? If you see here in the spreadsheet editor, so now the values which were there in the mesh category is gone, and we have values under the curve, a 24 curve control point and 12 spline. But if you see the points, this is a point, this is a point, and this is a point domain. Okay, but if you see the points have increased. If you see, I can mute this with M, and you can see there were 8 vertices before, and as soon as I put in a mesh to curve node, the control points have increased. What exactly is going on? So to understand this, we can put in a instance on points, so we can clearly see what exactly is going on with the points between mesh and curve. Okay, so for instance on points node to work, we need an instance. We'll see details about each nodes in a separate videos, and that will help you to understand deep into each node. But for now, let's put icosphere into the mix. This will be the instance. So I'll reduce the size. So you see, we had 8 vertices, we had 24 control points, but now we have 24 instances. But if you see 1 2 3 4, only 8 you see. Okay, what's going on here is, I'll just mute mesh to curve, so this will bring only mesh. You can see the instances reduced to 8 now. If you see, unmute 24, mute 8. So what it happens is, when I don't consider this mesh to curve node, only 8 points are considered. You see here, so mesh has 8 vertices and instances will be 8. And when I activate it, we have 24 points into the mix and we have 24 instances. But we don't see the 24 because I'll mute instance on points also to explain a little bit. So when you have a mesh, your vertices are direct data of vertices is considered. That is called position of each vertices. So this position is an attribute. Okay. Now when I activate just the mesh to curve point, then we have curves. Now you have 12 splines. Okay, each of the edge is a spline, and let's say each of the edge corner is a control point. If I want to compare it one to one with the mesh, you can see edge has 12, face corner is 24. If I activate again, spline is 12, control point is 24. And what is attribute doing here is it's defining this curves with an extra information. So point domain has different information when it comes to mesh and curve, but the position attribute and the UV map attribute will have the set of data needed to define this particular curve. And when I activate this instance on points, you have 24, but you don't see the 24 here. That's because each of this point will have two more hidden in it. Okay. For that to be revealed, you need a random rotation and random scale so that you can see it. Even now you can see it. So okay, so there's random. If I mute this, you can see. So there is some more in this mix. A scale random value will reveal it. Okay. Okay. Now if you see, one moment. For rotation, we'll put a maximum rotation 2 times pi. That will bring a full circle, so you can get maximum rotation. That will reveal more information about the hidden instances. Okay, if I reduce this, yeah, now you can see. So each of this has two more hidden in the same position. So that's why we don't see all 24, but you have instances created on the same point or same location 3 times. Okay, so if I put a subdivision into the mix, let's hide this for now. Okay, hiding is not good. We just need to dismantle it. So these are called fields, the rhombus sockets. We'll see about it in a separate video because it has data or more information to be discussed. So I'll put a subdivision into the mix. Yeah, I want to subdivide the mesh before going it into the curve. Yeah, now you can see. So if you reduce the size, you can see you get a array kind of geometry already. We didn't do anything, we just added more nodes to the default geometry nodes, which will create a cube. And what happened with the subdivision? If you see with subdivision, I'll just mute again to explain a little bit on the subdivision, what's going on. So with zero subdivision, I have 8 vertices. Again, now I have more information on the position on each vertices. And if I activate the curve, the data from here is gone because we are now at evaluated state. So only what is evaluated so far. So we have a mesh, we have a curve, and the curve is now output. And because of that, we have attribute information of position attribute in curve section. So this will have, as I already said, it will have more control points very close to face corner value. So you see 96 face corner, and if I unmute this, 96 control points. Okay, and then when we move on to create an instance from this, so you lose this information, or let's say the evaluated part will not have this. The final output is actually instance, so information will be in instances. And you can see we have more attributes in this category. So it will have a geometry information, that is an attribute. UV map, that is an attribute used for textures. A position attribute is there. Okay, rotation scale. So what is this rotation scale? There are new ones because a position attribute was transferred from mesh to curve and even before mesh also. So from here, okay, from here, position attribute, even UV map. But what is this new ones? Scale, rotation scale. Rotation scale is coming from here. A new two attributes to define the position is defined already by this individual entry points of three-dimensional data, but we have some random rotation and random scale. So even though you say scale is just one, you still need that information because a certain rotation is defined and certain scale for each instance is also defined. So rotation, scale, position, UV map, these are all different type of attributes, and we have different data types also for each of the attribute that comes in. For example, it will have integer value, sometime it can have a float value, and sometime it can have a vector. Okay, so if I put this back in for random rotation, you can see I have muted it. I'll unmute it. So this has a vector value. So data conversion between the values is automatic. We can see about data conversion between the attributes using the fields concept, and that will help you understand more how seamless the data conversion between different types. Okay, for now what you want to understand is we have set of attributes that defines the geometry itself, its position, its scale, its rotation, and other aspects of it. And accessing the attributes is easy. You just need the right node to manipulate it. And from attributes point of view, you have this predefined attributes. These are set attributes that is already always available with the geometry. And you have anonymous attributes also, which will have information about a certain data, but you won't be able to see it in the spreadsheet editor. For now, this is just there and can be accessible with certain nodes. We will come to that later when we see each nodes in a separate video. For now, you need to just understand geometry has attributes in it, and this is the basic concept of geometry nodes, which is very useful to manipulate and to even get a desired geometry which you look from geometry nodes. So yeah, that's it about the attributes in geometry nodes. It's okay if you don't get it completely, but having a basic idea is sufficient and also necessary. When we go deep into the geometry nodes, we will be able to manipulate a lot of this data from the attribute section, and this will help you in creating the desired geometry that you want. If you find this video useful, please like it and share it with your colleagues and friends. If you want me to cover any other topic in Blender, please let me know in the comment section. I'll see you in another cool video.